Good evening everyone. I am Saranya, Assistant Professor, Computer Science and Technology from SNS College of Engineering. Today's my topic is Naive Bayes Classifier. Then what is Naive Bayes Classifier? It is a simple yet effective supervised machine learning algorithm is based on the Bayes Theorem. It is used for the classification task that assume the features are independent of each other given the class variable data set. The naive Bayes classifier is here. It's mainly used in the classification that includes the high dimensional training data set. A naive Bayes classifier is one of the simple and most effective classification algorithms which helps in building the fast machine learning models that can make a quick predictions. Then types of naive Bayes classifier. The first one is a Gaussian naive Bayes for the continuous data. Then second one is multinomial naive Bayes for the discrete data, and third one is Bernoulli naive Bayes for the binary or Boolean features. Then why it is called the naive Bayes? The naive Bayes algorithm is comprised of the two words. One is a naive, second one is basis, which can be described as the naive is here. It is called the naive because it assumes that the occurrence of a certain the features is independent of the occurrence of other features, such as here, if the fruit is the identified on the base of color and shapes and taste, then red, and the sweet fruit is the recognized as an apple. Hence, each features or individually contributes to identify that is an apple without depending on the each other. Then base it is called as the basis because it depends on the principles of Bayes theorem. The Bayes theorem. The Bayes theorem is known as the Bayes rules or Bayes' law, which is used to determine the probability of the hypothesis with a prior knowledge. It depends on the conditional probability. The formula of Bayes theorem is given as probability of P by A by B equal to probability of B by A into probability of A divided by probability of B, where probability of A divided by B is a posterior probability. It is the probability of hypothesis A on the observed event of B. Then probability of B divided by A is likelihood probability, the probability of the evidence given that the probability of a hypothesis is true. Then probability of A is the prior probability. It is the before observing the evidence of hypothesis. Then probability of B is the marginal probability. It is the probability of evidence. Then Naive Bayes classifier algorithm. The Naive Bayes classifier algorithm is a cornerstone of the Naive Bayes classifier because of its provide as way to calculate the posterior probability of probability C divided by D from the prior probability of C together with the probability of D and probability of D of H value is called as the Naive Bayes classifier algorithm. Here the formula of the Naive Bayes algorithm is the probability of C divided by D equal to probability of D divided by C into probability of C and divided by probability of D. Here the C map equal to argument max int capital P of C divided by D. The map is the maximum a posterior I equal to most likely classes. Here the small c epsilon of capital C is there. So it's normally used in capital C. Then the hypothesis value. Then argument max small c into epsilon of capital C equal to probability of D divided by C into probability of C divided by probability of D is a normal Bayes rules. Here that argument of max small c uh, belongs to capital C into probability of D divided by C into probability of C is the dropping the denominator of the hypothesis values. The Naive Bayes classifier is the task to classify the new distance of capital D is based on the tuple of attribute values of D equal to x1, x2 up to xn into the one of the base classes of small Cj belongs to C. Here the C map equal to argument of max into small j belongs to capital C into probability of Cj divided by x1, x2 up to xn. Here that the argument max Cj belongs to C, the probability of x1, x2, up to xn divided by Cj into probability of Cj, again that the divided by probability of x1 and x2 up to xn. Here that the argument max small c capital small c j belongs to capital C into probability of x1 x2 up to xn into divided by Cj into probability of Ci. Here that the previous equations of argument G max C j belongs to G into probability of x1, x2 and up to xn divided by Cj into P of probability of Cj divided by probability of x1, x2 up to xn. Here that common of P of x1, x2 up to xn into the both of two equations. Here that the final of argument max into Cj belongs to C into probability of x1, x2 up to xn the divided by Cj into P of Cj. Here the map equal to maximum a posteriori probability. Here the positions or all word positions in current document which contain tokens to found the vocabulary of written CNV where the CNV equal to argument max probability of Cj into cardinality of P of probability of xi divided by Cj into I belongs to the position Cj belongs to C.